In this video, let's see the diagonal form of a given matrix. You can see a matrix A here, -1, 3, -2, 4, and we are going to find the diagonal form and hence find A power 4. A power 4 will be very easy. A power 4, A power 10, all those things once if you convert it to diagonal form. So first of all, how to reduce it to the diagonal form. Already we have seen how to find out the eigenvalue and the corresponding eigenvector. So that is step 1. We have to find the eigenvalue. For that, what we will use? We will use the characteristic equation, that is determinant of A minus lambda should be 0. And remember, the diagonal elements only we will subtract minus lambda. So -1 minus lambda, and the next value is going to be the same, and here -2 is going to be the same. Again, the diagonal element is 4 minus lambda. Determinant of this is equal to 0. So we have to do cross multiplication. So -1 minus lambda into 4 minus lambda minus 3 into -2 minus 6. This minus and this minus will become plus 6 equal to 0. And if we simplify this, we will get the quadratic equation lambda square minus 3 lambda plus 2 is equal to 0. Already, as I told you, you can use the T method, that is, you have to write two values in such a way that if you multiply you should get 2, and if you add you should get -3. So we can factorize this as lambda minus 1 into lambda minus 2 is equal to 0. Therefore lambda is 1 and 2. So these two are the eigen values. Now we have to find the corresponding eigen vectors. So we got the two eigenvalues, that is lambda is equal to 1 and lambda is equal to 2. So remember the previous matrix, we got it from the characteristic equation, that is -1 minus lambda. So what we have done is A minus lambda I into x is equal to 0. This is what we have done. Okay. Oh my god, I have written somewhere else. A minus lambda I into, write it properly, into x is equal to 0. So -1, first term is -1 minus lambda into x, second term 3y equal to 0. Then -2x plus 4 minus lambda into y is equal to 0. So this equation we are going to substitute lambda is equal to 1. So if I substitute lambda is equal to 1, -1 here, -1, -1 will become -2x plus 3y is equal to 0. And from this equation we will get 2x is equal to 3y. Therefore x by 3 is equal to y by 2. So we got the corresponding eigenvector for lambda is equal to 1 as 3 and 2. Okay. If I substitute here, what I'll get? I'll get the same equation. Put lambda is equal to 1 means 4 minus 1 is 3. So I'll get -2x plus 3y is equal to 0. So we'll get the same equation. So that is why we got this eigenvector. Similarly, if you put lambda is equal to 2, what I will get? -1 minus 2 in this equation. So -3x plus 3y is equal to 0, which implies x is equal to y. And here we wrote the denominator values, right? And what is the denominator value here? 1. X by 1, y by 1. Correct? So x2 is equal to 1, 1 is the corresponding eigenvector for lambda is equal to 2. So finally, how to write the modal matrix P? So this value 3, 2 I have written in first column. Okay, that's a column matrix. And this one is 1, 1 I have written in the second column. This is your modal matrix. So now by using this modal matrix, how to find the diagonal matrix? Let's see. So now we got this modal matrix P. We wrote the first eigenvector here and then the second eigenvector here. Now we have to find P inverse. What is the formula for P inverse? 1 by determinant of P into adjoint of P. Normally for 2 cross 2 matrix adjoint, no need to take much tension. So what we are going to do is we are going to change these places. Okay. So if I change this place, 1 will come here and 3 will come here, and change the sign for the rest of the two. So -2 -1. Just if you do this, this is easy. And determinant of P, 3 into 1 minus 2 into 1. So 3 minus 2, 1. So determinant of p value is 1. So 1 by 1 into, and this place change and the sign change I said, right, adjoin. So 1 by 1 into 1 minus 1 minus 2, 3. So this is P inverse. Now we have to find P inverse AP. This will give you the diagonal matrix. So P inverse is what we got now, and A is given in your question, and P is what we've got in the beginning, P inverse AP. So first we have to multiply. Anyhow, this is a 2 cross 2 matrix. The resultant also will be a 2 cross 2 matrix. So first row, first column. Multiply very carefully. 1 into minus 1 plus minus 1 into minus 2. So what we will get? Yeah. So I have written this, that is 1, and then first row, second column. So 1 into 3. So I have written 3, then minus 1 into 4. So 3 minus 4 minus 1. So first row, first column over, first row, second column over. Now second row, first column. I'm just teaching matrix multiplication. So second row is this and first column is this. So minus 2 into minus 1. So you will get plus 2, I have written here, plus 3 into minus 2. So minus 2, plus 2 minus 6, so we get minus 4. And the second row and second column. So minus 2 into 3, so that is nothing but minus 6, I have written this here, plus 3 into 4. So minus 6 plus 12, 6. So we have multiplied the first two matrix, then the resultant we have to multiply with the third matrix. So we multiplied the first two matrix, we got this one, and this is the second one. So 1 into 3, then minus 1 into 2. So 3 minus 2, you will get 1. And then first row, second column, 1 into 1 plus minus 1 into 1. So 1 minus 1, 0. Then second row, first column, 4 into 3, 12. And then is this minus 4, right? 1 minus 1, yeah. So minus 4 into 3, minus 12. Then plus 6 into 2, plus 12. Minus 12 plus 12, we will get 0. And finally minus 4 into 1 plus 6 into 1. So 6 minus 4, we will get 2. Because only the diagonal elements will be there. If you see here 1 and 2. So this is the diagonal matrix for the given matrix A. Okay. So P inverse AP will give you the diagonal matrix 1, 0, 0, 2. So now we have to find A power 4 or 5, whatever it is. The general formula is A power n is equal to P into D power n into P inverse. So now we have to find A power 4, right? So P into D power 4 into P inverse. So this is nothing but A power 4 is equal to, what is P? 3, 1, modal matrix we got in the beginning, right? 3, 1, 2, 1. And then this diagonal matrix, one advantage is power 4 means 1 power 4, 1, 0, 0, and 2 power 4 is 16. That's it, we are done with this. And P inverse is, remember we changed the place and sign, and we got 1 minus 1, and determinant value also you got as 1. So this is, again we have to do matrix multiplication and try to simplify by yourself, and you will get this answer. So we are done with this. So what does the advantage means? Instead of multiplying it 4 times, or even if it's A power 10, 10 times instead of multiplying, this diagonal matrix power is very easy. So we can use this and just only this multiplication. 3 matrices will be there, and this is nothing but your A power 4. Thank you.